Hi everyone, welcome to My Maths Academy. In this video, we'll continue with the chapter Arithmetic Progression, which is your chapter 5 from your 10th standard CBSE Mathematics. And we will start with the next section, which is nth term of an AP. In page number 100 of your textbook, nth term of an AP. So before we go to the nth term of an AP, let's write the general form of an AP. So general form of an AP is what? It is A, comma A plus D, comma A plus 2D, comma A plus 3D, comma dot 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 dot. So this is the general form of an AP, where this is the first term, this is your A1, this is your A2, this is your third term A3, this is your fourth term, and so on. Right? So your A1 is basically the A, first term, and your A2 is A plus D, and your A3 is A plus 2D. Now if you observe, right, this can be written as A plus D can be written as A plus 2 minus 1 into D, and 2 minus 1 is 1. Again this A plus 2D can be written as A plus 3 minus 1 into D. Similarly, this A can be written as A plus 1 minus 1 into D. So similarly, A4 is A plus 3D, which can be written as A plus 4 minus 1 into D. Now, what is the use in writing in this form? So if you observe, if it is A4, then it is 4 minus 1 into D. If it is A3, A plus 3 minus 1 into D. If it is A2, then A plus 2 minus 1 into D. So like that, if you want to find any general term, this is called a general term or nth term. General term, or it is also called as nth term. General term or nth term. Nth term is denoted by an. So A1 means first term, A2 means second term, A3 means third term, A4 means fourth term, an means nth term. Now nth term is given by, if you apply here, so if it is 4 here, I should put 4 here. So an becomes A plus, it is n. The value of, if it is 4, it is 4. Here it is n. So it will become n minus 1 into D. So if I put n is equal to suppose 4, I'll get A plus 4 minus 1 into D, which is this, which is A4 I'll get. If I put n is equal to 3, here I'll get A plus 3 minus 1 into D, which is A plus 2D. I'll get A3. So this is the formula to find any general term of an AP or nth term of an AP. If you want to find the nth term, any general term, that is, we call it as the nth term of an AP, then we can use this formula A plus n minus 1 into D. So an is equal to A plus n minus 1 into D is called as the nth term of an AP. Right? Where your A is the first term and D is the common difference, and n denotes the number of terms in the AP or the position of the term in that AP, and an is the nth term. Fine. So now with this, we will try to solve few problems using the concept of nth term of an AP. So let's go to problem number or example number 3. So this formula you need to know. an equal to A plus n minus 1 into D. Fine. Now let's go to example 3 in page number 102 in your textbook. So example 3, EG3 means example 3. Let's say what is given in the question. So given in the question is, find the nth term where AP is given 2, 7, 12. So AP is given as 2, 7, 12 dot 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 dot. It's an AP. Now we have to find the 10th term of an AP. So we have to find 10th term. 10th term of the AP. So 10th term of the AP means we have to find A10. 10th term of an AP means what? We have to find A10. A10 denotes the 10th term of the AP. A2 is second term. A3 is third term. A4 is fourth term. So if you want to find the 10th term of the AP, this AP, we have to find A10. So this is first term. First term is 2, second term is 7, third term is 12. Now what will be the 10th term? That's the question. So A10 we have to find. So solution is, what is the formula for an? an is a plus n minus 1 into d, right, which is this. And we want to find a10. 10th term means we should find a10, which means we should find a10, which is a plus 10 minus 1 into d. So in the place of n, I am putting 10. So n in the place of n, I am putting 10. So this is a10. You will write a suffix 10, right? Below a, you will write 10, right? So like this, a small 10, a10, something like that, right? So a10, this is a small n, suffix n, right? a10 equal to a plus 10 minus 1 into d. So that is equal to a10 becomes a plus 9d. 10 minus 1 is 9d. Now we should find a plus 9d. And what is a? A is the first term, which is 2. So a is first term. So first term is a, small a, that is 2. And your common difference is d. Common difference, that is your d, that is a2 minus a1. That is your a2 minus a1. And that is equal to, what is a2? a2 is 7. This is a1, this is a2, 7 minus a1 is 2. So 7 minus 2, which is 5. Fine. So we have found d also, right? Now let's substitute a and d in this formula, right? So a10 is equal to a plus 9d. So a10 is equal to a is 2 plus 9 into d, d is 5. So you get 2 plus 9 5s are 45. So your a10 becomes 47, right? So the 10th term of the AP is 47. So the 10th term is 10th term of the AP, of the given AP or of the AP is 47. 47 is the 10th term of the AP. Fine. So whenever they ask you to find a particular term, we'll use this formula an equal to a plus n minus 1 into d, which is, this denotes the nth term of an AP. And if you put n is equal to 10, you'll get the 10th term. Right? In the place of n, if you put 10, you get the 10th term. Right? So now let's go to example 4. So EG4, example 4, the next one. What says is, which term of AP is 81? Right? Also, is any term 0? Give reasons for your answer. So they are saying which term. So AP, which term of AP, and what is the AP? AP is 21, 15, sorry, 21, 18, 15, dot is 81. Which term of this AP is 81? So if we keep on writing 21, 18, 15 like that, which term will become minus 81? Sorry, minus 81. Which term is minus 81? Also, is any term 0? Also, any term is 0. Is any term is 0? Also, is any term 0? Also, is any term is 0? Now, key reasons for your answer. Now, we have to find in this AP, minus 81 is which term? Right? In this AP, dot is minus 81. The solution is, now which term of the AP is 81? See, the first term is 21, second term is 18, third term is 15. Like that, if we keep on writing, minus 81 will become which term? Which means we have to find the value of n. So we will say, let's assume that minus 81 is the nth term. So let an equal to minus 81. We are assuming that the nth term is minus 81, nth term of this AP, and we have to find what is n. We have to find what is n. So now, what is an formula? An is a plus n minus 1 into d. That is your an, this formula. And that is equal to minus 81. Now we should find the value of n. And we know a and d because a is the first term and d is the common difference. Let's find what is a. The first term a is what? A is 21. And what is d? D is a2 minus a1. And a2 is 18. Minus a1 is 21. Now 18 minus 21 is minus 3. You have to be careful with the sign, minus 20. So your A is 21 and your D is minus 3. Now let's take this equation again. I'll write it here. So what we have? We have A plus n minus 1 into D is equal to minus 81 and A is 21. So 21 plus n minus 1, n we don't know, n is what we are finding, and D is minus 3. Minus 3, this is your D. So we are substituting A and D in this. So you get 21, then minus 3 into n is minus 3n, minus 3 into minus 1 is plus 3, equal to minus 81. Now we should solve this and find the value of n. Now 21 plus 3 is 24, so minus 3n plus 24 equal to minus 81. So minus 3n is equal to minus 81. This 24 goes to the other side, becomes minus 24. So minus 3n will become minus 105. So n is becoming minus 105 by minus 3. Your n becomes 35. The value of n is 35. Therefore, your minus 81 is the 35th term of this AP. Minus 81 is the 35th term of the given AP. Therefore, we'll say, so therefore A35 is minus 81. Because we assumed it as an is minus 81 and n we have found it as 35. So A35 means it is the 35th term. So 35th term of the AP is minus 81. The 35th term is minus 81, right? Because n is 35. 35 means n is 30. So 35th term will give you 81. So if you write it, this is first term, second term, third term, like that. If you keep on writing till 35th term, the 35th term will become minus 81. You will get minus 81 there. Now, is there any term 0? We have to check whether 0 will be coming. If we keep writing this, will somewhere 0 will come or not, right? If you try to go there, whether 0 will come or not. So we have to check whether is 0 is the term of this AP. So we don't know whether 0 will come or not. If we keep writing whether 0 will be one of the terms or not, we need to check whether 0 is the term of this AP. So for that, we will assume that again the nth term is 0. So let's say, so let an equal to 0. Let's assume that the nth term is 0 again. We have to find what is that n. For which value of n, your an becomes 0. So now again an formula is what? A plus n minus 1 into d equal to 0. Because see, earlier we checked minus 81 is which term. Now here they are not saying 0 will come. They are asking whether 0 will be one of the term. Which means we will try to find n, what that n is. And that n that we are going to find, obviously n denotes the number of terms. So it should be a positive integer. We cannot get n as negative or fractions. If n is negative or fraction, then 0 will not be the term. 0 cannot come as a term in this AP. If n is a nice positive integer, then it is a term of the AP. Now let's, what is A? A is same. The value of A is 21. Let's substitute that here. So 21 plus n minus 1 into d. What is the value of d? D is minus 3. So let's put minus 3 equal to 0, right? So then 21, then again minus 3 into n is minus 3n. Minus 3 into minus 1 is plus 3 equal to 0. So minus 3n, 21 plus 3 is 24 equal to 0. So minus 3n equal to minus 24. Your n becomes minus 24 by minus 3. So n becomes 8. So now n is a positive integer. So which means n is 8. So your eighth term will be 0. Eighth term of this AP will be 0, or the eighth term of the AP is 0. So therefore, so we'll say A8 is 0. N is 8 means A8 is 0. Therefore, eighth term of the AP is 0. So 0 is the term in the AP and its eighth term is 0. The eighth term of the AP is 0. So if you keep on writing, this is the first term, second term, third term, like that. If you write the eighth term, you will see that eighth term will be 0. And if you continue to write, your 35th term will be minus 81, right? This is minus 81. Fine. So all of you can pause the video and take the notes. I'll go to the next example, which is example 5. Let me erase this. So example 5 is what is given. What is given is, the question is, determine the AP whose third term is 5 and seventh term is 9. So what is given? We have to find AP. So what is given? Given in this question is third term is 5. Third term is 5 means A3 equal to 5. Third term means A3. Second term means A2. Nth term is AN. So third term is 3. Sorry, third term is 5. So A3 is 5 and seventh term is 9. Seventh term means A7. That is 9. So third term is 5 and seventh term is 9. We have to find the AP. Determine the AP. So we have to find AP. So to find this, find the AP or determine the AP. Determine the AP means we should write the list of numbers. We have to write some 3 to 4 terms of that AP. Right? Determine the AP means we have to find the list of numbers in such a way that the third term should be 5 and the seventh term of that AP should be 9. Now solution. Now what is given? A3 is 5. So A3 is 5 is given, which means the third term is 5 if that is given. But what is A3 formula? A3 is A plus 3 minus 1 into D. Right? Because your AN is A plus N minus 1 into D. That is your AN. Your AN is A plus N minus 1 into D. So A3 will be A plus 3 minus 1 into D. Because your AN. Formula for AN is A plus N minus 1 into D. So if I want to find A3, A3 will be A plus 3 minus 1 into D. Right? So in the place of N, I have to put 3 to find A3. So A3 is 5 is given. So instead of A3, I can put A plus 3 minus 1 into D is equal to 5. So which means A plus 3 minus 1 is 2. So 2D equal to 5. This is one equation. Then the second one is A7 is 9, which means seventh term of the AP is 9. So A7 is given as 9, but A7 can be written as A plus 7 minus 1 into D. That is equal to 9. A plus 7 minus 1 into D, that is 9. So which means A plus 6D equal to 9. Now again here AN, in the place of N I am putting 7 because it is 7. Right? So AN is 7 minus 1 into D. Now A7 is A plus 7 minus 1 into D. So A plus 6D is 9 because 7 minus 1 is 6. Now this is your second equation. Now whenever we want to find the AP, we need to know A and D. If you know the first term and if you know the common difference, then we can find the AP. We can write the first few terms of the AP. So to find A and D, we have these two equations. So we have to solve these two equations with any one of the method, elimination method or substitution method, whatever. It's a linear equations in two variables. So I'm going to write the equation. So A plus 2D equal to 5. This is first equation. And A plus 6D equal to 9. That is your second equation. Now let's subtract both. So minus elimination method. Minus minus cancel. 2 minus 6 is minus 4D equal to 5 minus 9 is minus 4. So you get T is equal to 1. Right? So we'll get D is equal to 1. So minus 4D equal to 4 means D is equal to minus 4 by minus 4, which is 1. So we found D. Common difference is D. Now substitute D is equal to 1 in any one of the equation. We'll take the first equation. A plus 2D is equal to 5. I'm going to put D is equal to 1 here. So A plus 2 into D. D is 1 equal to 5. So that is A plus 2 into 1 is 2 equal to 5. So A becomes 5 minus this 2 goes to the other side. It becomes minus 2. Plus 2 will become minus 2. So A is 3. Now we found A, the first term, and D, the common difference. Once you know A and D, we know the AP. So what is the general form of the AP? So general form of the AP is general form of AP. See, this is general term of an AP. This is general form of an AP is what? A, comma A plus 2D, A plus D, comma A plus 2D, comma A plus 3D, comma dot 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 dot. This is the general form of an AP. So here you substitute A and D here. We'll find the AP. We'll get the AP. So A is 3, comma A plus D. A is 3 plus D is 1, comma A plus 2D. A is 3 plus 2 into D is 1, comma A is 3 plus 3 into D is 1, comma, dot, 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 dot. Now what will this become? So this becomes 3, comma, 3 plus 1 is 4, comma, 2 into 1 is 2, 2 plus 3 is 5, comma, 3 1s are 3, 3 plus 3 is 6, comma, dot, dot, dot. So your AP is what? AP is, hold on, if you put 3, comma, 4, comma, 5, comma, dot, 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 dot. So if you observe, the third term is 5. And if you write till the seventh term, you will get the seventh term as 9. So you can write first 4 terms, you can put 3, 4, 5, dot, dot, dot. Right? We need to substitute the value of A and D in the general form of an AP. You always write 4 terms and substitute A and D in each of the term. You will get the 4 terms, then you put dot, 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 dot. That's it. So this is the given. This is the AP in which the third term is 5 and the seventh term is 9. Third term is 5 and seventh term is 9. So we were supposed to find the AP and we found the AP. AP is this 3, 4, 5, 6, dot, dot, dot. So that is your answer. Fine. Now let's go to the sixth question. Example 6. Let me write here. So what is example 6? Example 6 is they said check whether 301 is the term of the list of numbers. So given is the list of numbers. So they are not saying given is an AP. So they say that given is a list of numbers. So list of numbers. Given is list of numbers. List of numbers. What are they? They are 5, 11, 17, 23, dot, 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 dot. We have to check whether 301 is a term of this. Right? So what we should check? Check is whether 301 is a term of this list of numbers. List of numbers. So in this list of numbers, will 301 be a term? If I keep on writing 5, 11, 17, 23 like that, will 301 be one of the terms of this given list of numbers? So here, one observation is you have to be very careful. They have said list of numbers. These they have not said it is an AP. In the question, it is not given that the list of numbers they don't form an AP or they are not. We don't know whether it's an AP or not. It's just a list of numbers. Now, the first thing is before even finding whether 301 is a term of this list of numbers or not, we should confirm whether the given set of numbers form an AP. Only if it is an AP, only if it is an arithmetic progression, then we can use all this formula. AN is A plus N minus 1 into D, first term, last term, common difference and all that. If not, we cannot use any of the AP's properties of an arithmetic progression. We cannot use any of the formulas of AP if this given list of numbers is not an AP. First, we should check whether it is an AP or not. So how do we check whether this list of numbers is AP or not? So solution is we need to check if the given list of numbers form an AP. So which means let's start writing the numbers. So how do we know that whether this list of numbers is an AP? We will find the common difference. What is the common difference? If the common difference is same, then it's an AP. So common difference D is A2 minus A1. And A2 is 11 minus your A1 is 5. 11 minus 5 is 6. Again, find what is A3 minus A2. We have to check for all the two consecutive terms. A3 is 17 minus A2 is 11. And 17 minus 11 is also 6. Again, D is A4 minus A3. A4 is 23 minus A3 is 17. That is also 6. Now all the common difference is same. So common difference is same. Therefore, it's an AP. Common difference is same. Therefore, it is an AP. Therefore, the given list of numbers. Therefore, it is an AP. Which means the given list of numbers, they form an AP So which means now we can start applying the formulas of AP to check whether 301 is the term of this list of numbers. So we will say let an equal to, whenever we don't know which term it is, which term of which, whether 301 is a term means we'll assume that 301 is the nth term of the AP and we should find n. So let an equal to 301. An equal to 301. Suppose a term is coming, the 301 is coming here, and suppose that is the nth term of the AP. Suppose if it is, then what is that n? We should find that n. Then, so an is a plus n minus 1 into d equal to 301. Right? Now what is a here? A is the first term, which is 5. Right? Here a is what? It's an AP with a is 5 and your common difference d is 6. So whenever you have an AP, always write the first term and the common difference, because these two are the key numbers which are used to find any other information of an AP. So these two are very important. The first term a and the common difference d. So first term is 5 here and the common difference is 666, which is 6. Now substitute here. A is 5 plus n we don't know, that is what we are finding. N is n and d is 6 equal to 301 or 301. So 5 plus n into 6 is 6n, minus 1 into 6 is minus 6 is equal to 301. So 6n, 5 minus 6 is minus 1 equal to 301. So your 6n equal to 301 plus 1. Your 6n is equal to 302. So your n is equal to 302 by 6. What we have got our n as? 302 by 6, and 302 by 6 is what? If you divide, these two can be cancelled by 2. You get 151 by 3. So 151 by 3. To simplify. Now 151 by 3 is not an integer. It's a positive number, but it's not an integer. It's a fraction, because 151 doesn't get divided by 3. 151 doesn't get divided by 3. Therefore, 301 is not a term in this AP. 301 is not a term in this AP, because if we keep on writing, we'll never get 301. We may get something like 299, and then we may go to 307 or 308 or whatever. We will not get 301. So after some point you may get 298. After that we may get 304 or something. We will never get 301, because n, for if 301 is a term of an AP and we get n as 151 by 3, which is not a positive integer. This is not an integer, it's a fraction. Right? So we will say n is n is 151 by 3. So n is equal to 151 by 3, which is not a positive integer, which is not NOT, which is not a positive integer. Therefore, 301 is not a term of the AP. 301 is not a term of the AP. It's not a term. It will never come as, the number 301 will not come if you keep on writing. 301 will never come. Like, so you may get some 298, after that it may go to 302 or 303. So 301 will never come, because your n is not a positive integer. Suppose if n is a nice positive integer, suppose if you get n is equal to 50 or 35 or 42, right, positive integer, then 301 will be a term of that. Suppose if this comes as 50, n is 50, suppose, then we can say the 50th term of this AP is 301. That case we can say that the 50th term of AP is 301 if n was 50. But n here is not 50, or it's not a positive integer. Any positive integer, if it is, then we can say it's a term in the AP. If n is not a positive integer, which means if n is negative or a fraction, it is fraction, then we can say that 301 is not a term of this AP, or 301 is not a term of the given list of numbers. Fine. The next one is 7th one, example 7. EG 7. Right, example 7. So what is example 7? Let me erase these. So example 7 says, how many two-digit numbers are divisible by 3? How many two-digit numbers are divisible by 3? Now, how many two-digit numbers are divisible by 3? That's a question. Now, let's start writing the list of two-digit numbers which are divisible by 3 first. Then we will know how many are divisible by 3, right? So now what is it's only two-digit numbers, right? So solution. The two-digit number, which is the first two-digit number? 10. The first two-digit number is 10. Is 10 divisible by 3? No. So we will not write that. The next number is 11. Is 11 divisible by 3? No. Next is 12. 12 is divisible by 3? Yes. So 12 is the first two-digit number which is divisible by 3. 12 is the first two-digit number which is divisible by 3. Then the next number that is divisible by 3 is what? 15. Because 13 is not divisible, 14 is not divisible. Next number that is divisible, next two-digit number that is divisible by 3 is 15. Then the next number is 18. You just need keep adding 3 to this. Then after 18, 18 plus 3, 21. Like that it keeps on going till what number? Now, which is the last two-digit number that is divisible by 3? Now, before finding which is the last two-digit number divisible by 3, let's find what is the last two-digit number. Which is the last two-digit number in mathematics? 99. 99 is the last two-digit number, or the greatest two-digit number is 99. Right? Then is 99 divisible by 3? Yes. So that is the last number that is divisible by 3. Then there is the last two-digit number divisible by 3. So the first two, you have to write the first two-digit number, then you have to write the last two-digit number, and then the remaining few terms in the beginning. Right? After 12, you know the next number will be 15. The next number that is divisible by 15 after 12 is the next number that is divisible by 3 after 12 is 15. The next number divisible by 3 after 15 is 18. After 18 it is 21 dot dot dot, which is the last two-digit number divisible by 3, 99. Now, if you see this list of numbers, if you see this, they form an AP. Why? The common difference is same. So what is the common difference? 15 minus 12 is 3. 18 minus 15 is 3. So the common difference is 3. Right? So we will say common difference, which is D. Let's find what is A2 minus A1. A2 is 15. 15 minus 12 is 3. Similarly, A3 minus A2, which is D. That is, A3 is 18. 18 minus 15, A2 is 15. That is also 3. Then D is A4 minus A3. Fourth term is 21 minus third term is 18, which is also 3. So the common difference is same. Therefore, this given list of numbers is an AP. Form an AP. So common difference is same. So first we should check whether the list of numbers is an AP or not. Is same. Therefore, it is an AP. Therefore, it is an AP. Now we need to know how many two-digit numbers are there. This is the first number. This is 1, 2, 3, 4. Like that, what will be this number? How many numbers are there? If you count them, 1, 2, 3, 4. Like that, if you count, how many numbers are there? That will give the number of two-digit numbers that are divisible by 3. So to find this, we should know what is the n here. So this is A1. This is your first number, A1, first term. This is A2, this is A3, this is A4. Like that, what is this? We don't know. We call that as AN. We call that as AN. And we have to find n. And that n is the answer. That n will tell how many numbers are divisible by 3. So we will assume that the last term 99 is AN. So we will say let AN equal to 99. Which means we assume that there are n terms in this AP. Totally n terms are there. First term, second, third, fourth, like that n terms are there. We have to find n. Now AN formula is what? A plus n minus 1 into D. That is 99. A plus n minus 1 into D, that is 99. Now what is A? A is the first term. So let's write what is A. In this AP, what is A? The moment it is an AP, we'll write A. So A is 12, the first term. And what is D? D is common difference 3. So whenever you say something is an AP, it's always better to write the first term and the common difference. First term and the common difference. Now let's substitute here. So A is 12. Let's substitute 12. Plus N is what we have to find. So N is N and D is 3. Equal to 99. So 12 plus 3 into N is 3N. 3 into minus 1 is minus 3 equal to 99. Then 12 minus 3 is 9. So 3N minus plus 9 equal to 99. Right? 12 minus 3 is 9 plus 9. So 3N is equal to 99 minus 9. This 9 goes this side. So 3N is equal to 90. Your N becomes 90 by 3. Your N is equal to 30. Your N is equal to 30, which means there are 30 numbers that are divisible by 3. There are 32 digit numbers that are divisible by 9. So this will become A30. So A30 means 1, 2, 3, 4, like that. If I count, there are 32 digit numbers which are divisible by 3. So therefore, how many numbers are divisible by 3? There are 2 digit numbers. There are 32 digit numbers divisible by 3. So there are 32 digit numbers that are divisible by 3. Clear? And this 30 is coming from N equal to 30. So there are 32 digit numbers divisible by 3, which are divisible by 3. Fine. So you can pause the video and take the notes. I'll go to the next example. I'll erase this. Example 8 is important example. Now example 8, EG8. Example 8 is very important. So find the 11th term from the last towards the first term for the AP. So what is given? Given as an AP. Given as an AP which is 10, 7, 4, minus 62. Minus 62. Now we have to find the 11th term from the last towards the first term. From here we have to start counting which is the 11th term from the reverse. Like 1, 2, 3, like that. In the reverse we have to count what is the 11th term from the reverse. Find the 11th term from the last term means from here which is the 11th term. If this is first term, second term, like that we have to go reverse and find what is the 11th term. Generally we go like this: first term, second term, third term, and we get 11th term. But in this problem we should find what is the 11th term from the last term towards the first term. Which means from the last term you have to keep moving, and which will be the 11th term. You consider this as the first term from the last. First term, second term, third term, like that. If you try to find the term from the last term towards the first term, which will be the 11th term. Which will be the 11th term of this AP. So it can be done in 2 ways. This problem can be done in 2 ways. Fine. So the first way is, let's try to find the solution. Right. So I will say what we have to find. To find, I will write find also. To find the 11th term. The 11th term from the last term. 11th term from the last term towards the first term. Towards the first term. Fine. So the 11th term. The 11th term from the last term towards the first term. What is that? Find the 11th term. Find the 11th term from the last term towards the first term. So solution is, let's try to find. There are 2 ways. I'll put method 1. There are two methods to do this. Method 1 and method 2 is very easy. I'll teach you the method 1, then we'll do method 2. We can use any one of the methods to find this. So method 1 is, let's try to find first of all how many terms are there in this AP. So which means we have to find what is this term. So this is first term, second term, third term. What is this term? So how many terms are there in this AP? Let's just find that first. Only then we can try to find which is the 11th term from the reverse. So I'll write here. So the terms are 10, 7, 4, comma, dot, minus 62, comma, right? So now what we will do is, we will try to find how many terms are there in this AP. So let's find the terms of, so we'll say let an equal to minus 62. So this is a1. Fine, see, this is your a1, this is your a2, this is your a3, like that, dot, if this is an. This is your an, right? So we'll say let an equal to minus 62. Now we need to find what is n. That n will tell what is the number of terms in this entire list of numbers which are in AP. So again, an is, what is a? A is the first term, which is 10. And what is d? D is a2 minus a1. And what is a2 minus a1? a2 is 7. Minus a1 is 10. And what is 7 minus 10? Minus 3. So always try to find d using a2 minus a1. Don't try to do it in the mind. If you do it in the mind, you may write it as 3 by mistake instead of minus 3. Right? Here it is 7 minus 10. Don't do 10 minus 7. So always write the formula d as a2 minus a1, then find the value of d. So it is minus 3. So we know the first term, we know the common difference. Just substitute here. What is an? An formula is a plus n minus 1 into d. That is equal to minus 62. Because your an is this. Instead of an, I am writing this equal to minus 62. Then a is what? 10. 10 plus n minus 1. N is what we are finding. Into d. D is minus 3 equal to minus 62. So 10, then minus 3 into n is minus 3n. Minus 3 into minus 1 is plus 3. You have to be careful when you multiply. Minus 3 into n is minus 3. Here there is a plus. That plus and minus will become minus. Then minus 3 into minus 1 is plus 3. Equal to minus 62. 10 plus 3 is 13. So minus 3n plus 13. 10 plus 3 is 13. Equal to minus 62. Minus 3n is equal to minus 62. This plus 13 goes to the other side. It becomes minus 30. So minus 3n is equal to minus 75. 75, yes. So n becomes minus 75 by minus 3, which gives you 25. So how many terms are there in this given AP? There are 25 terms. So there are totally 25 terms in the AP. 25 terms in the AP. Now we should find the 11th term from the reverse. Don't find A11. Right? Totally there are 25 terms in the AP. N is 25 means there are 25 terms. So 1, 2, 3, like that. If I count, this will become A25, which means 25 terms are there. Now they are asking us to find the 11th term from the last, not the 11th term. If they say find the 11th term, that is different. That is A11. If they say find the 11th term from the reverse, means from the reverse, what is the 11th term? We have to find. So which means, see, this is your A25th term. Because we got this as A25. I'll write here. This is AN, we put it as AN. Now it has become A25. Because we know N is 25. Now I can change. Earlier we did not know what was N. So I had put it as N. Now we know N. So it is A25. So this is 25th term. A25. Right. Now this is the first term from the reverse. This is the first term. This is A1 from the reverse. If I am trying to go from the reverse. So this is first term and this will be second term, right? Like that it will go. And this will be which term? This will be A25. Because from the reverse, if this is the first term from the reverse, then second term is some number which we will find. Third, fourth, like that if it comes, the last term from the reverse is 25, A20. This will become the last term, which is the first term from this direction. In this direction, this is the first term. From this direction, from the reverse, it is the last term, which is 25th term. So the 25th term in this direction is the first term in this direction, in the reverse direction. Right? So now if you observe, so this will be what term? Obviously, if this is A25 from the reverse, this is the 25th term from the reverse, then this will be A24, right? And this will be A23. Now what we should find? We should find what is A11 from this direction. So suppose if this is A11 is here. A1, A2, dot, 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 A11. We have to find the 11th term from the reverse. So this is A11. Suppose this term is A11. We have to find what is that number. We have to find that number here. A11 corresponding to A11. Now if you observe, if the reverse direction is 11, in the normal direction what will be this position? Suppose if this is the number box, that is the number which is A11 from the reverse. So what will be the corresponding value here? A3, what will be this position here? From in this direction, what is the position of this? So to find that, let's observe the, so suppose if it is A1, first term is the 25th reverse direction, 25th term. Second term is the 24th term from the reverse. The second term in this direction is the 24th term in this direction. Now if you observe, what is 25 plus 1? You add the numbers which are suffixed to A. 25 plus 1 is 26. 24 plus 2 is also 26. 23 plus 3 is also 26. So which means if you add the position of the normal direction and the reverse direction, we always get 26. We always get 26. So this 23 plus 3, 26. Then 24 plus 2, 26. 25 plus 1, 26. 25 plus this one, 26. Therefore, A11 with something here also should give me 26. So A of what will give me 26? A15. Because 15 plus 11 will give me 26. Right? If you add these numbers, this 2 and 24 gives me 26. Again 3 and 23 gives me 26. So which means this 11 plus something should give me 26, the total. So if this is 11, this has to be 15. Only then if I add these two, the positions of the normal position and the reversed position, if you add, we should get 26. So if this is 11, this has to be 15. That's when I add, I get 26. So which means the finding the 11th term from the reverse is same as finding the 15th term from the first term. So the problem now it has become, find the 15th term of this AP in this direction. 15th term means this, which will be the 11th term from the reversed direction. So to find the 11th, the question is to find the 11th term from the last, which means from the reverse direction, which is same as finding the 15th term from the first term. So if you want to find the 15th term from the first term, which is A15, then we can apply A plus n minus 1 into D. But for if it is A11 here, we can't put A11 is A plus 11 minus 1 into D. For this A11, you can't apply the general form an equal to A plus n minus 1 into D because this is the 11th term from this direction. And the formula that we have, an is A plus n minus 1 is always for this direction. From the first towards the last. If the flow is in this direction, only then we can use an as this form. So corresponding to this direction, we have found what will be the position in this direction. The position in this direction is A15. Clear? So what we are going to do is, I'll write the continuation here. So we'll say the 11th term from the last term towards the first term is equal to 15th term of the AP. 15th term of the AP means this is the 15th term. 15th term is this. Right? This we don't call it as 11th term. It is the 11th term in the reverse direction. If there is a A11 here, that we will call it as 11th term. But this is the 11th term from the reverse. We don't call that as the 11th term of this AP. It's the 11th term from the reverse. That is different from the 11th term from this direction. So the 11th term from the reverse is same as the 15th term in the normal direction in this way. So we have to find, instead of finding the 11th term from the last term is same as finding 15th term of an AP, which is equal to A15. We have to find A15. For A15, we can apply the formula A plus n minus 1 into D because This A15 portion is in this direction, A1, A2, A3, like that A15 is coming. So we can apply the formula, this one. So we have to find A15. So what is A15? A15 is A plus n minus 1 into D, right? Or I'll put 15 minus 1 into D because n is 15. So which means A plus 14D. Now we have to find that. We have to find that A plus 14D. Fine. Now, so A15 is A plus 14D. So that is equal to A. A is what? The first term is 10. That is your A. 10. 10 plus 14 into D. D is what? Minus 3. So minus 3. So that is 10 plus 10 minus 14 times 3 is 42. So your A15. The A15 is minus 32. So the last term. So this is minus 32. Right? So the last term, the 11th term from the last term is minus 32. So the 11th term from the last term towards the first term, is equal to minus 32. Equal to minus 32. That will be the 11th term from the reverse. 11th term from the reverse, if you calculate, it will be minus 32. So this is one method to do it, right? The other method that we have is how we can find the 11th term from the last term is we will reverse this AP, the given AP. So method 2 is to find the same answer, the 11th term from the reverse. To find this, we will try to write the reverse AP. So we will reverse the AP. So we will say the reverse AP. Reversed AP. What is the reversed AP? Which means you should write this as the first term, minus 62, comma. Then we don't know which is the next term. We'll write that. We'll put dot 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 and 4, comma 7, comma 10. 4, comma 7, comma 10. Now we have reversed the AP. Right? We have reversed the AP. Now what is this AP's first term? A is minus 62. The first term of this AP is minus 62. Now for this we should find the 11th term. After you reverse the AP, for this AP, if you find the 11th term, we will give the 11th term from the reverse because we reverse the AP. So this is now this has become A1. Right? Like that we have to find A11. If you find the 11th term of this AP, the reversed AP, that will be the 11th term of this AP from the reverse. So now we reverse this AP and we are finding A11. Right? To find the 11th term from the last, either you can follow this method or the easy method is you reverse the AP and in the reversed AP you find the A11. For the reversed AP you find A11, that will be the 11th term of this AP in the reverse direction. Right? So now A11 we have to find for this AP. Now A is minus 62. What is D? D is A2 minus A1. We don't know A2, but any two terms you can take to find the D. Let's take these two. 7 minus 4. This is 7 minus this term minus this term. Don't do this minus this. This minus the previous term. So 7 minus 4 is what? 3. So common difference is 3 and not minus 3. Because you have to do this minus this. 7 minus 4. The current term minus previous term is the common difference. Now we know A and D. Let's find A11. What is A11? A11 is A plus 11 minus 1 into D. A plus n minus 1 into D. In that general formula, in the place of n, I am putting 11. So A plus A is how much? Minus 62 plus n minus 1. 11 minus 1 is 10 into D. D is 3. So minus 62 plus 30 is minus 32. That is your A11. So the reversed. So again, the 11th term from the last term of this AP is the 11th term of this AP in this direction, which is same as this direction. For this AP, it is the reverse direction. From this AP, it is the normal direction. So if it is the normal direction, then we can use the formula AN equal to A plus n minus 1 into T. So therefore, the 11th term from the reverse, 11th term from the reverse of the given AP, given AP means this AP is equal to minus 32, and both the methods we got the same answer, minus 32 minus. So you can use any one of the methods to solve this, but I would say you use this method because this is easy. Whenever they ask you to find the the 11th term or any particular term from the last term, you reverse the AP and find the 11th term. If they say what is the 13th term from the last term, you reverse the AP and find the 13th term. To find the 13th term, you can use the formula A plus n minus 1 to d and then find the 13th term. If suppose the question is to find the 13th term from the last term towards the first term. Fine. So this completes example 8. So I'll go to example 9. All of you can pause the video and take the notes. I'll go to example 9. So example 9 is EG9. That is given as a sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. Do these interests form AP? If so, find the interest at the end of 30 years making use of this fact. This use of this fact means that it is an AP fact. So let's try to write what is given. So sum, which is principal, is given. Principal is how much? The money, right? Principal is rupees 1000, right? That is the principal. And what is simple rate of interest? Rate percent is 8%. Now and it is simple interest. Calculate the interest at the end of each year. Now first we should calculate the rate of interest end of each year. So we will calculate for first few years. First 3 years we will calculate. So interest at the end of the solution. So first we should calculate the interest at the end of each year. We should find the interest at the end of each year. Then those interest, the list of interest, right? What is the interest at the end of first year? What is the interest at the end of second year? What is the interest at the end of third year? Right? Then we have to check whether those form an AP. If they form an AP, then we have to find what will be the interest at the end of 30 years. Right? So let's find interest at the end of first year. First year will be what? That is PTR by 100. That is the formula. PTR by 100. Right? Simple interest. So P is 1000 into time is 1 year. Rate of interest is 8 by 100. So if you do this, you'll get 80. 1 2 1 2 gone. Right? So interest at the end of second year. We have to find the interest at the end of second year. That will be equal to again PTR by 100, P into T into R by 100. That will be equal to 1000 into time. Time is 2 years because it's at the end of 2 years. Right? At the end of second year means 2 years is the time. 2 into rate of interest is 8 by 100. So cancel these two, you get 16 into 10, 160. 16 into 10 is 160. Now again we'll calculate the interest at the end of third year. That will be equal to PTR by 100. That is equal to principal is 1000 into 3 years into 8 by 100. So 2 gone. So 24 times 10 is 240. Now we will list the interest. So the interest at the end of each year. At the end of each year is as follows. Right? Is as follows, which means 80 at the end of first year, 160 is the interest at the end of second year, 240 is the interest at the third year, then dot dot dot. Now we have to check whether this list of numbers form an AP, right? So for that, what do we find? We will find common difference. What is common difference? Common difference is A2 minus A1. What is A2? 160 minus 80. So 160 minus 80, which is 80. A2 minus A1. That is D. Common difference is D, which is equal to A2 minus A1. Again, let's find what is A3 minus A2. 240 minus 160. 240 is A3 minus A2 is 160. That is also 80. So the common difference is same. Therefore, it's an AP. Right? Since the common difference is same, therefore it is an AP. Which means the given list of numbers, they form an AP. Now, what they say that once it forms an AP, then find the interest at the end of 30 years. We have to find what is the interest at the end of 30 years. So the interest at the end of 30 years will be the interest at the end of 30 years will be equal to A30, the 30th term of this AP. Right? See, this is A1 is the interest at the end of first year. A2, this is A1, this is A2, A3. A1 is the interest at the end of first year. A2 is the interest at the end of second year. A3 is the interest at the end of third year. Therefore, interest at the end of 30th will be A30. So we have to find A30, 30th term of this AP. So what is A30? So A30 is equal to A plus 30 minus 1 into D. A plus 30 minus 1 into D. And what is A? A is the first term. So whenever we say it is an AP, it is always better to write A. A equal to what? The first term, 80. And D is equal to, D is also 80. Right? So A is 80 plus 30 minus 1 is 29 into 80. So that will be 80. If you take 80 common, you get 1 plus 29, which will be 80 into 30. You get 2400. So that will be the interest at the end of 30 years will be rupees 2400. That will be the interest at the end of 30 years. Right? So this is your answer. Right? So all of you can pause the video and take the notes. I'll go to the next one, which is example 10. Now example 10. So EG10 is example 10. So example 10, what it says? It says in a flower bed, there are 23 rows in the first row, 21 in the second row, 19 in the third row, and so on. There are 5 roses. There are 5 rose plants in the last row. How many rows are there in the flower bed? So there is a flower bed. In this, 23 rose plants are there in the first row. Right? So I'll probably write, try to draw. Suppose if this is your rose plants. Right? Like that, how many are there? 23 are there in the first row. Then in the second row, again some roses. I'm sorry, my diagram is so horrible. I'm not good at drawing at all. So this is the second row where there are rose plants. You think this has rose plants. The second row has 21. 21 of them are there if you count. I'm just drawing approximately. Similarly, you have the third row which has rose plants. How much? We have 19. Like that, if you go, the last row have only 5. The last row has only 5 rose plants. Now we need to find how many rows are there. 1, 2, 3, like that if you count. 1, 2, 3, 4, like that if you count, how many rows are there? Right? So we'll say solution is Now we need to know how many rows are there. So this is the first row. The first row has 23 rows plants. Second row has 21 rows plants. Third row has 19 rows plants. Like that, the last row has 5 rows plants. Last row has 5 rows plants. We don't know how many rows are there. We have to find that how many rows are there. Which means we will say the number of rows plants in each row is, we'll write that. So 23 in the first row, 21 in the second row, 19 in the third row, like that, 5 in the last row. Now to find how many rows are there, this is one first row, second row, third row, like that. If I want to find, and I will call this as nth row, the last row as nth row, and we have to find n. That n will give the number of rows in this flower bed, right? So we will say let. Now we'll first try to check whether it is an AP first, right? We'll check whether it forms an AP. So again, common difference is what? Common difference is D, which is A2 minus A1. And what is A2? A2 is 21 minus 23, which is minus 2. Right? Similarly, if I find A3 minus A2, so D equal to A3 minus A2. If I find that, I'll get A3 is 19 minus 21, that is also minus 2. So since the common difference is same, therefore it's an AP. Since common difference is same, therefore it is an AP. Which means this given set of list of numbers form an AP. Now we will assume the last term as an. So let an equal to 5, which means there are n rows. There are totally n rows, right? And the last row has 5 flower beds, right? So an is 5. An is what? A plus n minus 1 into d, that is equal to 5. And a is what? The first term. So here, once we say it is an AP, we'll write the first term is 23 and the common difference d is minus 2. That we'll write. First term is 23 and the common difference is minus 2. So a plus n minus 1 to d is 5. So we have assumed that there are n rows. Now we will find what is the value of n. Now a is 5. No, a is 23. Sorry, 23 plus n minus 1. N we don't know. Into d. D is minus 2 equal to 5. Right. So 23 minus 2 into n is minus 2n. Minus 2 into minus 1 is plus 2 equal to 5. So you get 23 plus minus 2n plus 25 equal to 5. The minus 2n is equal to 5 minus 25. 25 goes to the other side, right? So this 23 plus 2 is 25. Then 25 goes to the other side. So minus 2n becomes minus 20. So your n is equal to minus 20 by minus 2. Your n is equal to 10. N is equal to 10. So the last row has 5 rows plants. And how many rows are there in total? If you count this 1, 2, 3 like that, there are 10 rows. So we'll say, so there are 10 rows in the rose bed, in the flower bed. The flower bed has 10 rows. So there are 10 rows in the flower bed, right? There are 10 rows in the flower bed because we assumed that this is as the last row, that an. N denotes the number of rows. So an is 5. Suppose the last row has 5 rows plants. Last row has 5 rows plants. So that we'll take the last row as an, nth term of this AP. So which is the last row. So we have to find n. Once you find n, those number of rows are there. So this is your first row, second row, third row, like that. If you do, this is your 10th row because n is 10. So there are 10 rows in that flower bed. Fine. So all of you can pause the video and take the notes, and you can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.